Hello, my name is Thomas Spada. I'm a master's student in the MAT program for chemistry. I recently was hired on at Bryan Station High School for my first year of teaching. I'll be teaching physical science and chemistry. It'll be new and hopefully be a fun experience for me, and I'll learn a lot. To give a brief overview of my experiments, we'll be conducting an experiment to collect data to show the conservation of energy and the transfer of energy. And this relates to the NGSS standard, the high school standard, physical science standard 3-4. We'll be touching the first law of thermodynamics. Specifically, we'll be conducting an exothermic reaction, which I'll explain later. And we'll also be discussing enthalpy, which is the total energy of a system. And we'll be measuring the change in enthalpy through the heat of the system. Also, in our experiment, the cup is, everything inside the cup is going to be the system. The cup itself is the boundary, and everything outside the cup is the surroundings. So, to get started, we have about 100 milliliters of distilled water, and we have about 2 teaspoons of yeast. And then we also have about 100 milliliters of 3% hydrogen peroxide. So the first step is going to be mixing the yeast into our distilled water. And we start mixing. And it's important to get it nice and uniform, not have big clumps in there. I'm doing now. Alright, that looks pretty good. You guys want to look in the cup. And then the next step is actually to take the temperature of our mixture. And it should be about room temperature, it might be a little bit warmer. It's reading at about 23.1 degrees Celsius. That's pretty close, so let's wipe that off. In the next step, we will take the temperature of the hydrogen peroxide, and we're at about 23 degrees. That's pretty close to each other. That'll work. And our next step is the fun step. We will take our system, see it's empty, simulated system, insulated, and we will pour our yeast and distilled water mixture with our hydrogen peroxide mixture, and we're going to see what happens. We should get a reaction, and we'll measure the temperature of the reaction. So pour it in. You might be able to hear it fizzing. If you look in the cup, you can see that there's fizzing going on, so a reaction's happening. And I'm going to take the temperature of the cup, of the new mixture, and we see that it's significantly higher than what it was prior to mixing those two together. And that's without adding any external heat from a heat source. So all the heat that we're seeing is coming from the reaction. And that's actually the definition of an exothermic reaction, is a reaction that releases heat. So if we look at our little diagram here, we see that A and B at the top of the graph, which are reactants. So the reactants are what you put into the reaction. When we mix those together, it runs through the reaction progression, and we get C, which is the product. We see that in this exothermic reaction, the energy of the products is actually less than the total energy of the reactants. So that's actually the change in enthalpy, and it is represented by a negative number. And in a reaction that has negative enthalpy, heat is being released to the environment. Energy is transferred from the system, which is the cup, and it's transferred to the environment in the form of heat, and we measure that heat when we put the thermometer in the mixture, and we saw the temperature was higher. that will conclude my experiment. I appreciate your all's time, and I look forward to your all's comments and questions and anything else you have for me. Thanks.